Welcome to Brain Vision.
In this question, we have to determine what is the maximum angle theta that the crutch can make with the ground in order not to slip. We begin this question analyzing the force that the ground exerts on the crutch of the right. So, on this one, the force that the ground exerts on that crutch has two components. One vertical component, which I will call F component Y, and one horizontal component, which I will call F component X. We can recognize these two components as the two components of the contact force. The vertical component is the normal force, and the horizontal component is the frictional force. Now remember that the maximum value of the frictional force is given by the static frictional coefficient times the normal force. And then the normal force is the y component of the force F. Therefore, this is mu component S times F component Y. And this is the maximum frictional force. Now, how can we relate F component Y with the force F, the complete force? We can do it as follows. This is a rectangle triangle, and here we have F component X, F component Y, theta, and the complete force as the hypotenuse. Then, we can use the cosine of theta to calculate F component Y. The cosine of theta is equals to F component Y divided by F, which is the adjacent side of the triangle divided by the hypotenuse. Then, F component Y is given by F times the cosine of theta. Therefore, the maximum frictional force is given by mu static times F times the cosine of theta. But now, note that the frictional force is also equals to the x component of the force F. Then, F component X is equals to mu S times F times the cosine of theta. Then, we can also calculate F component X using the angle theta. We can use the sine for that. So the sine of theta is equals to the opposite side of the triangle F component X divided by F. Then F component X is equals to F times the sine of theta. Then F times the sine of theta is equals to mu S times F times the cosine of theta. Then we can cancel out F on both sides of this equation and solve for mu S. We get the following: sine of theta divided by the cosine of theta, which is the tangent of theta. Therefore, theta max, the maximum angle, is given by the inverse tangent of mu S, which is the inverse tangent of 0.9, which is approximately 42 degrees.